So here's my f of x and here's my g of x. You remember how just a second ago we talked about these operations of functions? We had f plus g, f minus g, f times g, and f over g. Now what I want to talk about is this. Now, I need to be very clear, this does not say f times g. It also doesn't say fog, even though it looks like fog. But I have to be honest, a lot of times when we talk about this, we talk about fog. Not the actual fog, but this right here. Okay? Because what this means is f of g of x. Another way to write it is like this. Okay? Remember when we talked about like f of 2? What did it mean when I said f of 2? That meant I was going to talk about f of x, but anywhere there was an x, what was I going to write instead? So like that, right? I don't need that equal sign right there. Just kind of like that, right? Y equals 4 times 6, so y, or f of 2, really equaled 10, didn't it? Let me change that, f of 2. So what if inside, instead of saying 2, it said g of x? Would you know what to do? So I'd start writing f, right? Because that's the thing on the outside here, or in this case, the first thing. I'd start writing f. So f of x equals 2 times, but I'm not going to put an x there. I'm going to put a g of x there. Right? Anywhere there's an x, I'm going to substitute a g of x, right? But guys, don't we know what g of x is? It's this one, right? So I'm going to keep going by substituting in what I know g of x is. Now, is this something we could simplify? It is, isn't it? Okay. So, actually, I need to make this g of x right there. That should be g of x. Sorry. So, I'm going to distribute here and here to get, let's see, 2 times 1/2 is, or half of 2, which is 1, right? So I just have x. And then 2 times -3 is -6. Huh. X? Well, here's the deal. If I could do f of g of x, couldn't I do g of f of x as well? Okay, we're going to do that, and I want you to watch what happens this time. Okay? So I'm going to start with g, because that's the one on the outside. That's this one right here. So I'm going to have 1/2, g of f of x equals 1/2 times f of x minus 3. Well, do I know what f of x is? I do, right? So 1/2 times 2x plus 6, and then minus 3. So let's distribute here and here, and I get x plus 3 minus 3. Huh. What kind of relationship did these two functions have to begin with? Do you remember? Remember where these came from? They were inverses, right? I chose those two particular on purpose because when you do fog, if I call this one fog, what am I going to call this one? Goff, right? When I do fog and Goff, when I do composition of functions on inverse functions, look what happens. Look what they both equal. It's not even the fact that they both equal the same thing. It's the fact that they both equal x. Why is that special? Why is that important? What did I do at the very beginning of this problem to find an inverse function? So I kind of made them equal, didn't I? I switched them and gave them the other value. And at the end, what did I find? I find that they equal x. That y, or the function, equals x. That's pretty cool. Okay? So on your homework, you're going to be asked to do a couple things. You're going to ask to do some of this operations with functions. You guys seemed pretty cool with that. Is that true? Okay. You're going to be asked to find an inverse. If it asks you to find an inverse, all you have to do is switch x and y and sometimes solve for y, right? That's all you have to do, just like this. Okay? What if it says, though, verify these two functions are inverses? We're doing composition of functions. We're doing Fogg and Goff. Okay? Do you have to do both of them? Or can you just do one and figure out that it equals x? If you do one, you've done half the proof. If you've done one, you've shown only half of the proof. So you do have to do Fogg and Goff to verify that two functions are inverses of each other. Okay? Now, what if I do Fogg and I get f of x equals 2x? Do I have to go do Goff? What if I just proven if I got x equals or y equals 2x? That's correct. I've proven that they're not inverses. I don't have to go and do the other one after all. You okay with that? Okay. Now, the last thing I want to show you real quick, and I have a piece of graph paper right here. I want to show you something about these two equations when I graph them. Okay. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I'm going to try to not to stutter or repeat my vowels and consonants and do it kind of quickly. So that's f of x, right? I'm going to graph g of x in red. I'm going to go down 3. 1, 2, 3. I'm going to rise 1, run 2. All the way to the edge. I'm going to fall 1 and run backwards 2. I want you to notice that in this particular case, these two functions meet. Where do they cross? 1, 2, 3, 4, 5, 6, 7, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They cross at -6, -6. What's important about that? They both equal the same thing. So if I graph the line y equals x on this graph, isn't that where my inverses should meet? That's where they should cross. Isn't that cool? I think it's pretty cool. It's like one of those things that like a whole bunch of things work together and suddenly it's like boom. Okay? Is it possible for inverse functions not to cross? How? What if it's two parallel lines? Will they cross? Could you still get inverses though? Yes, they'll just have the same slope, right? Is it possible for you to only have one line if you find an inverse? What if my line goes like right perpendicular? Didn't it meet right here? So an inverse could be itself. Wouldn't that be interesting to look at? Here's what's cool. I don't know if you can be able to see it. I know you'll be able to see it by looking back here. I don't know if you'll be able to see it on the screen. But if I took this and I folded it right along that line y equals x and held it up to the light, guess how many lines I see? Yeah? Part right there and part right there. Because it lies right on top of each other when you fold it. You can even kind of see it like this. You can see the reflection right there and right there, can't you? Inverse functions are pretty cool. Okay? Any question on operations of functions or finding an inverse or verifying an inverse? What's this called again? Do you remember? This is called composition of functions. Okay? Any questions on that?